All right. So, hello and welcome everyone. So, we are live right now. So, I welcome all of you to this amazing platform, Tutee Learning. So, today we are going to definitely discuss about another very important concept, and that is going to be on the topic of the concept of mirror image of a point with respect to a particular line, keeping it as a mirror, right? So today our lecture is going to be a very interesting lecture. Okay. So before I start with the ongoing discussion, I would like to ask you, all of you, I hope you have tried to solve this particular problem to find out the equation of the angle bisector for the two lines, right? So let us say that you have two straight lines and you have to find out the bisector or the angle bisector, right? So I hope you have all tried to solve this problem. So today, as we proceed with this particular discussion on the angle bisector concept, now we are going to discuss about how I can predict that which of the following bisector is going to be my acute angle bisector and which of the following bisector is going to be my obtuse angle bisector, right? So today we are going to learn about this particular important concept, right? So if you recall from the last class, we discussed about that the concept of angle bisector was as follows. So if I have two equation of line a1x plus b1y plus c1 divided by square root of a1 square plus b1 square, and that is basically equals to plus or minus a2x plus b2y plus c2 divided by square root of a2 square plus b2 square, right? So we have discussed this part in our previous discussion. So if you are not familiar with this particular discussion, I would request you to please go back and watch the previous lecture. Okay, so please go back and check out the previous lecture that I have taken so far on this particular concept, right? So we discussed this is how we get to the equation of angle bisector, right? So in case we need to get to the angle bisector, okay, be it an obtuse angle or acute angle bisector, we have to use by this particular equation, right? So this will give you the locus or the equation of the angle bisector, right? And the concept was very simple, is that if you have two lines, let us say this is line 1 and this is line 2, so the equation of the angle bisector is basically that particular line which is equidistant from the both the lines, right? So that was what we have discussed in our previous lecture. So today I'm going to discuss about a shortcut method, a shortcut techniques. Okay, so you can call it as shortcut method to identify to identify the acute and obtuse angle bisector, right? To identify the acute and obtuse angle bisector, right? So this is would be our main aim to learn in this particular lecture. So as we already mentioned that my line 1 and line 2 are as follows from the previous discussion. So these are the equation of my line 1 and line 2. Okay, so having this particular equation of the line 1 and line 2, I can use it to predict the uh, acute angle and the obtuse angle bisector, right? So how will I know that which of the following, whether I should use the plus sign or the minus sign to get which bisector, right? So how will I know that? So to identify that particular thing, the most easiest way is basically, first of all, if I have this following lines, I have to check whether my a1 b2, whether my a1 b2 is not equal to a2 b1. Okay, so this particular value should not be equal, and also I should have c should be positive. Now before I go on to use this particular shortcut, it is very important to remember that I can apply this particular shortcut such that I will make my c1 and c2, the constant part, be positive. Okay, now maybe you are given the line equation where c1 and c2 are not positive, right? So in that particular case as well, so you have to first of all make this c1 and c2 positive, right? Otherwise you cannot apply this particular formula or this shortcut method, right? So if I have this particular thing out here, the condition that I will check is that if my, so the conditions So I'm writing over here the conditions. Okay, so the condition that I will check, and which particular sign will give me the acute angle bisector, and which particular sign will give me the obtuse angle bisector, that I'm going to decide, right? So based on this particular condition. So let us say the condition is, if I obtain a1 a2 plus b1 b2, if this particular expression value is positive, then the negative sign would give me the acute angle bisector and the positive sign would give me the obtuse angle bisector. In the similar manner, if I have a1 a2 plus b1 b2, if this particular expression is negative, in this case the positive sign of that particular equation would give me the acute angle bisector and the negative sign would give me the obtuse angle bisector, right? So this is a simple shortcut which can also be derived very easily. So if you just do it by the previous expression that I discussed in the class, so you can be easily able to get to this particular expression, right? However, as a mode of shortcut, you can take it as a learning, right? So if I have this following condition, then which of the following sign would definitely obtain me acute angle or obtuse angle bisector? This can be easily be taken up from this particular results. Okay. So by using this particular result or shortcut trick, you can definitely use it to apply to any types of question. But please note that before you apply to any type of problem, you should have this particular condition should be satisfied. This particular condition should be satisfied. Okay. So if this condition is not satisfied, please don't move forward with this particular uh, conditions. Okay. All right. I hope this is clear to all of you. Now please note that a line which is equally inclined to two given line is parallel to the angle bisector of the given line, right? So this is a very important note that I would like to announce over here, that if I have a line which is a line which is equally inclined to a given line, which is equally inclined to a given two lines, okay, given two lines is parallel to the angle bisector, is parallel to the angle bisector, is parallel to the angle bisector of the angle bisectors, okay, of the given line. Okay, so these are very important note, please take it as a note. So what you understand is that a line which is equally inclined to two given lines is parallel to the angle bisector of the given line. Okay, so these are very important understanding about the angle bisector. I hope this is clear to all of you, right? Okay, so please let me know the live chat so that we can start discussing about the important concept in today's lecture. Okay, so today we are going to discuss about the another important topic, that is going to be the foot of perpendicular, and following that we are going to discuss about the point of image. Okay, how do we find out the image with respect to a given mirror as a line? Okay, so that we will going to discuss in this particular lecture. Okay, is this part clear to all of you? Just let me know the live chat, is this part clear or not? Okay, just let me know the live chat, is this part clear, so that we can proceed with our discussion on the mirror image and the foot of perpendicular. Okay, so I hope this is clear. So let me now proceed with the concept of image of a point with respect to line as a mirror. Okay, so I'm writing the topic as image of a point. Okay, so the concept is, now this concept will be applied many of the places, even in engineering, right? So that makes this particular concept a very important concept. Okay, image of a point with mirror line, with mirror as a straight line. Okay, so I'm writing like this. So you have to find out the image of a point with mirror as a straight line, right? So in this particular concept only, we are going to learn about two important things, that is the foot of perpendicular, and secondly we are going to also learn about the uh, image about a particular line, right? So let us see how do we derive this particular expression, right? So let us say we have this as my straight line, right? So let us say this is my straight line ax plus by plus c is equal to 0. Okay, let us say this is my straight line equation, right? And if I want to find out the coordinate of the image of a point A, let us say this is my point A, this is my line L. So I want to find out the coordinate of the image of point A with respect to this line L as the mirror. Okay, so if I consider this as my mirror, okay, so if I have A dash as my mirror image, so then let us say the coordinate is x2 y2. So I want to find out what will be the coordinate x2 y2, right? So how am I going to do that? The simplest way to solve this problem we have already seen in our previous discussion of a point with respect to plane as a image, right, or a mirror, right? So what we did is that we found out the foot of perpendicular as well. So the basic concept remains the same. You can again solve this problem by applying the concept of vector as well, right? However, in order to apply this particular problem, what I'm going to do over here is that um, the concept is very simple. Let us also call the foot of perpendicular as C, and let us name the coordinate as x3 y3. Okay, so we will be finding out this x3 y3 and x2 y2, right? So how am I going to solve this problem? It's very simple. Let us first of all find out the slope of this line L. Okay, the slope of this line L would be equals to minus of A upon B. So from this equation of the line, I will get the slope of the mirror image or the mirror line, that is basically minus A upon B, right? So if I have the slope of this mirror line as minus A upon B, the slope of the line AC, it will be equals to, so this particular slope, let us say m, this particular slope is going to be equals to plus of b upon a, right? So this particular slope of the line AC is going to be equal to b upon a, right? So this particular slope of the line AC is going to be equal to b upon a, right? So and also I know one point passing through this point A, right? So with this I can write my equation of the line AC. So I can write the equation of the line AC, that is x minus x1 times the slope, that is b upon a, will be equals to y minus y1, right? Will be equals to y minus y1. So if I solve this, I will generate the equation of the line AC, that will be simply equals to, like, I will have x times of b and then minus a times of y is equals to b times of x1 plus minus a times of y1, right? So this is for the equation of the line, right? So just by solving this AC line, let us say this is equation number 2, and let us say this is my equation number 1. So by solving for equation number 1 and 2, I am easily going to get the foot of perpendicular. So by solving, so if you solve equation 1 and equation 2, we will get the coordinate of the point C, that is my x3 comma y3, right? That is going to be x3 comma y3, right? So if you solve it, you will see that the coordinate of x3 y3 is going to follow the relation as follows. So the relation will be given out as, so which is very similar to what you have studied in the planes. It is going to be x3 minus x1 by a is equals to y3 minus y1 upon b is equals to minus of ax1 plus by1 plus c whole divided by square of whole divided by a square plus b square. Okay, whole divided by a square plus b square, right? So this is what I will have as the equation of the or the condition which will help us to find out the coordinate of the foot of perpendicular, right? In a similar manner, if I need to find out the image point, so in order to find out the image coordinate, that is basically my a dash, so in order to find out the image coordinate, that is x2 y2, the only thing that will be coming extra is basically here it will be minus of, right? Instead of minus of 1, here it will be minus of 2. So the result is very simple. So it is x2 minus x1. So it is going to be x2 minus x1 by a is equals to y2 minus y1 upon b is equals to minus 2 times of ax1 plus by1 plus c. Oh no, sorry. Okay, let me write it again. So ax1 plus by1 plus c whole divided by a square plus b square, right? Whole divided by a square plus b square, right? So this is the only difference over here is that the only difference is basically you have a multiple of 2 over here, right? So if you just follow this particular expression, you are easily going to get to the relation of the coordinate for the mirror image. Okay, so if you just follow this expression over here, you will get the coordinate for this mirror image. Okay, so this is for the mirror image, and the previous one for point C was the foot of perpendicular. Okay, so this is the foot of perpendicular. All right, so these are the two important results that you need to keep in mind as we move ahead with solving some problems, right? So I would like to give you one problem to solve, all of you, and that would be, so, or also one more thing is to notice that you don't need to always use this particular formula, right? Maybe you can just use this form of to generate the equation of line AC, and then you can solve the two equation to get the foot of perpendicular, and then I can use the concept of section formula, because this foot of perpendicular is going to divide this A and A dash in the ratio 1:1, right? That is a midpoint, right? So you can use the midpoint formula to also obtain the coordinate for the mirror image, right? So it is up to you how do you do the computation, right? So one of the very standard JEE mains problem is shown over here. So I would like to give you that particular problem. Okay, so there can be any sort of variation. You have to just do the computation by yourself, right? So please do the computation. I am not going to do the computation over here. I'm just going to tell you the results. Okay, so this is the question that is a very standard problem, especially for JEE mains. So please try to solve this problem and let me know the answer in the live chat. Okay, so I give you some time to solve. User, sir, how many lectures are left for straight lines? See, for straight lines we are almost done. Okay, so there will be one more lecture regarding the family of straight lines, and we have to solve some more problems, right? Sir, you taught 3D geometry, vector algebra, and then coordinate geometry, straight line. Which order should I go with, sir? See, it will depend upon which particular level are you right now. If you are in class 11th, I would say you start with the straight line first, right? And if you are in class 12 and you are just revising, then you should start with the vector algebra, 3D geometry, and then you move to straight lines. Is this clear? Use your KV8TJ3VR. I don't know, so VR name. Okay. Is this part clear? Okay, so for straight line, you can hope that one more lecture I will take. Okay, and then we will go to discuss about the pair of straight lines of the conic sections. Okay, and then we are going to enter into circles, and following circles I will be doing with the hyperparabola, ellipse, and hyperbola, and then we'll be done, right? So you can assume that by the end of or by the mid of December, I am pretty much going to finish this entire portion of coordinate geometry. Okay, coordinate geometry is a very important portion, and especially it is quite easy if you just follow the results step by step. Okay, and if you just study the very basic part, like from the coordinate geometry what I have already discussed, okay, especially the properties related to triangles and all that, I think you will be able to understand it, right? Sir, please upload some more problem solving sessions. Yes, definitely. I hope you haven't followed us. Okay, please user, please subscribe to channel. Okay, I have already announced it. Okay, that we are going to start with our revision sessions from 26th of November. Okay, so from 26th November onwards, this should be basically 24th. Okay, I will update. Okay, so but definitely you can take this particular tentative date, the 26th of November onwards. We are going to start with one short mock test, okay, where we are going to only practice problems and quickly revise the entire theory, right? So it will be more of like a short note based session. Okay, it is a short note based session where we are going to definitely revise the concept in a real detail, not in very much detail, but we are going to definitely discuss as of the revision is concerned. Okay, and then we're going to solve question after question. Okay, so every session you can expect like at least 10 to 15 questions we will be definitely solving in the session itself. Okay, and then after that I am definitely going to give you some homework problems to solve, and if you are doing it with discipline and in, all those sort, and if you are trying your best to solve those questions and you are getting the results, then I think you are pretty much good with the JEE Mains paper, right? So that is going to start from 26th of November. Okay, so please try to follow those particular sessions from 26th of November, and I think you will be able to understand all of this stuff, right? And if you are looking for problems that I have already solved, you can check out the JEE Mains previous year question sessions. Okay, so I have already taken up previous year question sessions on JEE Mains for the last year. Okay, so maybe you can follow that particular stuffs as well, right? Okay, so please go to the channel once more. Okay, and I think you will be able to get it. All right, so keeping those topics apart, tell me the answer for this particular problem. What is the answer you are getting? What is the final answer you are getting? Please do let me know the answer you are getting. -1 -14. Okay, let me check whether it is -1 comma -14. Wonderful, wonderful user. The image coordinate, the coordinate of the image is -1 comma -14. Okay, great, great. That's great. I hope all of you are able to get to this particular answer, right? It's very straightforward. You just do the computation over here, right? All right. So with this particular part, we are almost approaching the end of our discussion on straight lines. So now we're going to enter into another important discussion, that is family of straight lines. Okay, so we are going to enter into the discussion of family of straight lines. Okay, which is a very important concept, especially when you are going to solve questions where they will directly ask you to have a particular line which is following some particular condition with respect to one line and the other line, and in that particular scenario you have to generate another set of straight line or another equation of straight line which is having the following properties related to the two lines, right? So in this particular case, the family of straight lines is going to help you a lot. So what is the concept? If I try to in short explain you this particular thing, let us say we have the equation of two lines. Let us say this is my line 1 L1 and we have another line L2. Okay, let us say we have the equation of these two lines. Now if I keep one property fixed to find out another equation of a general line, so the fixed property is basically I have to find out the equation of another line which is passing this point of intersection of this line 1 and line 2. So this particular line, if I want to find out this particular general line, okay, let us say this general line which is general. So given that I have the equation of line 1 as follows. Okay, so these are the equation of the lines which I know. Okay, so if I have this particular equation of line and I want to find out the general equation of this line L such that it is passing to the point of intersection, so let us call this point as P, so that the only common thing in between this particular thing is that it is passing to this point of intersection. So in that case, what we say is that by using this concept of family of straight lines, what we can say is and conclude that the general equation of any straight line passing through the point of intersection of these two lines L1 and L2 can be simply given as L1 plus lambda times of L2 will be equal to 0. Can be simply given as L1 plus lambda times of L2 is simply equal to 0. Okay, where this particular lambda can be any real number. So this lambda is the parameter which is varied to generate the different set of general line passing through this point of intersection of line 1 and line 2. Also, this general formulation satisfy the point of intersection for any value of lambda that is given to us, right? So this is called as the family of straight lines. Now why do we call family? Because it is having one common trait, right? That is passing to the point of intersection. So I can generate any set of line which is passing to this point of intersection, right? So I can generate infinite such set of lines which is passing to this point of intersection by varying this my lambda, just by varying my parameter lambda. I hope this is clear to all of you, right? So if you want to look into this proof of this particular problem real quick, let us say the point of intersection or the fixed point through which the line all the lines are passing, let us say it is xr comma yr, right? Let us say it is xr comma yr. Okay, so and if I consider any general equation of the line like this, right? This is a general equation of line. So if it is satisfying xr and yr, that means that x r a x r plus b y r plus c is equals to 0, right? So then, so this will be equal to 0, that is xr comma yr will satisfy the equation of the line. So if this is clear, then what I'm going to do over here is that a simple modification, that is I'm going to divide this particular line by another constant, which I can easily do because this is a constant expression, right? So I have already got the result which is equal to 0. So I'm dividing both the side by result of square root of a square by a constant value, that is a square plus b square, right? Which I can easily do, and that will be equal to 0 as well, right? So this is where, and what I can write over here is that this r is varied from 1 to n. What do I actually mean by this? This basically means that the fixed point is varied by saying that it is basically x of r comma y of r, where r can be any value, right? But xr and yr is the fixed point. So if I do that, and from here what I can say is that, or maybe like if this particular information is given to us, okay, if this particular information is given to us, what does this mean? This means that if I have a line which is of this particular equation, this particular line L, and if I have a fixed point xr and yr, the sum of the distance of different xr and yr on this particular line, if I take all the sum, it is basically equal to 0, right? So what I mean to say is that a straight line is such that the algebraic sum of the perpendiculars drawn upon it from any number of fixed point is 0, then the line always passes through a fixed point. That is the important for understanding, right? In order to understand the derivation of this particular form, what we have to understand is that the a straight line which is basically passing the fixed point has to be such that the distance from all the varied fixed point has to be 0. The sum of the perpendicular distance from all the varied fixed point is 0. Then we call that particular line to be a straight line which is passed through a fixed point. Okay, so this is a very important consideration that you need to understand. So if I apply this, then I can, the summation of all the perpendicular distance is basically equal to 0. And if I have this result, what I can do is, again, I can modify this expression, and I can write this expression as a times a is a constant times summation of xr plus b times summation of yr plus c would be equal to 0, or summation of c, right? So if I do this particular expression out, so from here what I can write and say is that this particular line is definitely going to pass through the point which is basically summation of xr and summation of yr, right? So the fixed point what I will get is that, so, and what I can also do is that, and also it should be divided by n, right? Because this c into summation 1 will be generating the values n, right? So if I remove the summation, I am dividing all the terms by n, right? So therefore the point where this particular line, or the fixed point that this line is passing through, is given as x1 plus x2 plus x3 and so on up to xn divided by n, comma y1 plus y2 and so on up to y of n whole divided by n, right? So this is where the particular set of line is passing through. I hope this is clear to all of you, right? So please take a note of this particular statement. So I'm trying to represent this particular statement. This is a very important statement, okay? So please take a note of this statement. So basis of this particular statement, I have found out the fixed point, okay? And therefore that particular line which is obtained by varying the lambda is basically the family of straight lines, right? So a straight line is such that, the algebraic sum of the perpendiculars drawn upon it from a number of fixed point is 0, then the line always passes through that particular fixed point, okay, through a particular fixed point, and that particular fixed point is already derived in front of us. So this is my fixed point through which that particular line is passing through, okay? I hope this expression is clear to all of you. I hope this particular expression is clear, okay? So I should definitely modify this. It should not be xr and yr. Just to explain it, I was basically explaining you this particular way. But this expression, now the point of intersection is also obtained to us, right? So now we also have the point of intersection, right? So I hope this concept is clear. So basis of this particular concept, we can use it to solve any types of problems, okay? So maybe a simple problem I would like to give all of you is that please try to find another equation of the line which is basically following some particular condition, okay? So this is the you have to find out the equation of the straight line passing through this point of intersection of these two lines, and also it is passing through point minus 1 comma 3. So again, very simple problem. So what you're going to use is that you have the equation of the two lines, so just use the equation of the line or that particular line which is passing through this point of intersection. Instead of finding out the point of intersection of line 1 and line 2, just use in terms of lambda and equal to 0, and just then follow, and you know that 1 comma 3 is lying on this particular line, so just satisfy this in this particular equation to get to the value of lambda. So once you get the value, you can directly comment on what is the equation of the line. I hope this is clear to all of you. So please try to solve this problem. Okay, so I hope this problem is clear. So maybe if you try to solve it out, you are definitely going to get to the correct answer. So the answer would be, so what I'm doing is that I'm writing down the answer. Okay, so you will definitely able to get the answer as 2x plus y, 2x plus y is equals to 1. So this is going to be the final answer. 2x plus y is equals to 1. So that particular equation, the line which is passing this point of intersection of these two lines L1 and L2, and also to the point minus 1 comma 3. So I hope this particular discussion is clear. So in this today's session, we have almost covered the entire chapter of straight lines, right? So starting from the equation of the lines to solving questions on different forms of the lines, angle bisector, foot of perpendicular image, and then finding out the perpendicular distance, okay, and finding out the distance between two parallel lines. All those concepts we have definitely discussed in details, right? So maybe in the upcoming lecture, we are going to definitely discuss about some standard questions that is very important, especially to understand this particular chapter, okay? And then following this particular, we are definitely going to start with pair of straight lines. So the next topic we're going to start with is the pair of straight lines, okay? So I'm announcing it over here. So the next topic would be pair of straight line, which is another continuation of this particular straight line chapter only, okay? So but in this thing, we are definitely going to understand the concept of conic section, okay? And why do we call this particular thing as conic section as well, right? So we are definitely going to discuss about that particular thing, right? So pair of straight line would be the next motto to discuss in our upcoming lectures. So I hope this particular discussion was fruitful enough to help you understand the basic concept. And even if you have any doubt, please don't hesitate, just put that up in the live chat or maybe in the discussion forum, okay? We have already our community with us, so please put your questions in the community and try to take the best use of all those particular material, right? And also join our Telegram channel so that you get access to the material. And also you can opt for the online one-to-one batches if you want to study live from me on one-on-one coaching platform, right? So that particular online tutoring platform is definitely for all of the students who are basically lagging in particular concept and want to take a one-on-one discussion or like a live class where they want to have a personalized attention and a personalized tutor, right? So for that, you can definitely contact us. The number is already given in the description box, and also it is floating on the live chat, right? So with this, I hope I was able to add some contribution or value to your particular preparation, and I hope to see you soon in our next class. So if you're into this particular platform, please subscribe to the channel and also hit the bell icon, okay? So with this, thank you, and I hope to see you in the upcoming class, and I wish you all the best. Thank you.